guys, so we're closer to getting caught up after the several missed days that we missed due to snow. So most likely next week or the week after, or next week, we're going to go back to the normal 3-day college kind of schedule once we get caught back up. Now, and what we did yesterday, I think was not too bad. Equations of circles, center and radius. That's really all there is to it, because once we find the center and the radius, we have the equation of circle, we can graph it. They're not that bad. What we're doing today, I think, is actually a little bit easier. It's equation of a line. And how many points do we need to form a line? 2. Because if we have 2 points, we can make a line. Now, normally, one of the points that we use, or two of the points that we use, are the x and y-intercept. Either normally we just take the y-intercept and slope, and we can make the line. Because once we plot this y-intercept, we use the slope, rise over run, and we have our second point that makes a line. Now, normally, what we call standard form is this right here. ax plus by equals c. Now, for overall graphing, this here, I think, is a little bit easier, or sometimes easier to graph. And the reason I say that is because if we look at ax plus by equals c, there's 2 points that we can get easily. The x-intercept and y-intercept. Because the y-intercept is the point where x is 0. The x-intercept is the point where y is 0. And since it is a line, we'll only have one of each. Now, we could have one or the other. That is possible, as there are lines that have an x-intercept but no y, and there's some lines that have a y-intercept but no x. If it only has a y-intercept, it means it is a horizontal line, flat line. If it only has an x-intercept, it means it's a vertical line, going straight up and down. So any other line except for vertical and horizontal lines will have an x and y-intercept. It's going to have to cross it at some point. And the reason I say that this is nice with these here is because if we think of ax plus by equals c in these terms, for the y-intercept, well, the x value is 0. So really, I can think of it just by equals c, divide by b, I have my other value. Not too bad. If I'm looking at the x-intercept, well, the y value is 0. Ax equals c, divide by a, we have the other point, we're done. That's why I think this is somewhat easy to find it, especially if it's given in this form. We don't have to do a whole lot to it. Now, if it's already given to us in point slope form, it'd be helpful if I didn't have an eraser out. Y equals mx plus b, point slope, or sorry, slope intercept form. Here, this is slope intercept, not point slope. This is slope intercept form. Well, the b value is the y-intercept, and m is the slope. So I can plot the y-intercept, use the slope. I now have the equation of the line, and we're good to go. And for those of you, I think all of you had me for geometry, except for I think one of y'all, or actually 2 of y'all, didn't have me for geometry. I don't know if your geometry teacher or Algebra 1 teacher explained why we call this slope intercept form. It's actually as straightforward as it seems. M is the slope, B is the y-intercept, so it's slope intercept form. Most things in mathematics are named exactly as they are. Now, out of everything, this is again another little side note. Ever wondered why we call slope M and not S? Kind of makes sense, doesn't it? M, this is really coming from the Greek and Latin, or Greek Latin. Their term, or kind of word for slope or increase or rise, comes from the word montagne, where we get our word mountain. M, slope. So from there, so we took it from them, we've kept it the same. Now the other form is point slope. We have a point and we have a slope. Point slope. Now, out of these three forms, standard form and slope-intercept are the easier ones to graph because we don't have to do a whole lot to it. If it's in point-slope form, we really need to get it back into slope-intercept form to have a better idea of how to graph it. But other than that, not too much so far. Graph the lines represented by each equation. So all we need to do is graph them. Now the first one, 2x plus 3y equals 6. Again, we need 2 points. Once we get 2 points, then we can graph it. The 2 main points, especially if it's in standard form, that I go for are the x and y intercepts. X and y intercepts. So we're looking at the x-intercept where y is 0. We're really saying that 2x plus 3 times 0 is equal to 6. Well, that's really just saying 2x is equal to 6. Divide by 2, so x is equal to 3. So one of the points is 3, 0. Same thing is true for the y-intercept. We're really saying 2 times 0 plus 3y equals 6, which is just saying 3y is equal to 6. Divide by 3, so y is 2. Three, 0, 0, 2. Those are our 2 points. Now, normally when we're doing this here, at this point here, we would get a straight edge, draw a straight line connecting the 2. And again, a straight edge is anything that has a flat side. So textbooks, pencils, ID cards, all have a straight edge. Just something to draw a straight line. Luckily for y'all, for the homework, you have a program that will create a straight line. So all you got to do is select those 2 points. Once you select the second point, it'll have the line created and you're done. That's it. You can go on. Questions on this here? So we good with the first one, yes? Now the second one is one that, especially in Algebra 1, geometry a little bit, not so much, most students have issues with, x equals -3. Because we're used to having a slope, we're used to having a y value also. But what we're saying here is that we want every value where x is -3. And I believe the way I think Miss Kendall helped y'all keep it straight, x, kind of like cartoon, they get an x over both eyes. And if we're kind of skateboarding or doing that, if we're going straight down, it's not going to end well. X. So, slope dude. X equals -3 is just a vertical line at -3. It's a straight up and down line. Whenever we have x equals, we're talking about a vertical line up and down. X equals is a vertical line. And the slope for a vertical line is undefined. It's undefined. Because we do have a rise, it is going up, but we don't have a run. Because slope is rise over run, so we're dividing by 0, which is undefined, but this is it. And the last one, 2y equals 4. Now, when we have y equals, we don't have an x, we're talking about a horizontal line. Now, we will not draw a horizontal line at y equals 4 for all the values there. because we don't have y equals 4. We have 2y equals 4. So we have to divide by 2, which really just is saying that y is 2. So we would just have a horizontal line that crosses the y-axis at 2, because all of those points on that line are where y is 2. And that's it. Questions on this here? Slope, m, that passes 2 points. What we have for this here, delta y over delta x. Delta y over delta x. And in mathematics, delta is just a way to say change. So what that's saying, delta y over delta x, is really saying that the change in y over the change in x. The change in the y values over the change in the x values is slope. So y2 minus y1 over x2 minus x1. Provided that x2 minus x1 is not 0. It's not a horizontal or vertical line. It's not going straight up and down. So we want to find the slopes passing through these points. y2 minus y1 over x2 minus x1. Now, the y value that we picked first doesn't really matter. The two y values that we have are negative 2 and 5. Which one do we want to put first? I'm just going to pick 5 minus negative 2. The order of the y values really, in all case and purposes or all case and points, doesn't make a big difference. I just need one first. So I put 5 first minus negative 2. However, whichever x value goes with that first y value, it has to go first. Since I put 5 first, its x value has to go first. Minus negative 3. So really, the reason the y values don't really matter too much because we're putting them in first. We just need one of them to go first, the other to go second. Then they match up to the bottom of the fraction. Now 5 minus negative 2 is 7. 3 minus negative 3 is 5. So the slope is 7/5. And again, you can plug this into a calculator, let the calculator do it for you, and we're done. That's it. Now for the most part, problem A is not that bad. There's not that much to it. Now for B, we'll do the same thing. So we can say 0 minus negative 7 over, since 0 went first, negative 5/2 minus 1. Now this one here is a little more quote-unquote challenging, mainly because we have a fraction and a fraction. That's the only real thing here. The numerator 0 minus negative 7 is just 7. Negative 5/2 minus 1 is negative 7/2. Which would give us negative 2. The calculator, when you say 0 minus negative 7 over negative 5/2 minus 1. Calculator will do it for us. We don't have to do simplifying the fractions or go through the whole process, because the TI 30XS will do it for us. So the slope is negative 2. If we remember with slope, if we're going for a point from negative 2, it means we're going down to right 1, or we can go up to left 1. Because if it's negative, we need to go in a negative direction for one and a positive direction for the other. Because up is considered positive, left is negative. Down is considered negative, right is positive. If it's positive, Here we can go up 7, right 5, or down 7, left 5. If it's positive, we use 2 positives or 2 negatives to plot or use the slope. If a line going from left to right is going up, it's considered positive. If it's going down from left to right, it's considered negative. If it's horizontal, it has 0 slope. If it's vertical, it has undefined slope. Given a line with slope m and y-intercept 0, b, the slope-intercept form is given by this here. So the first thing we want to do is write the equation in slope-intercept form, determine the slope and y-intercept, and then graph the line. Well, if we want to rewrite this in slope-intercept form, all we need to do is solve it for y. We need to get y by itself. So the first thing we can do is subtract 3x from both sides, telling us that 4y is equal to negative 3x plus 4. And the last thing we need to do to get y by itself is to divide everything by 4, telling us y is equal to negative 3/4 x plus 1. Now the slope is negative 3/4. Just the number in front of m. Or not the number in front of m, the number in front of x, which is m, which is negative 3/4. Our y-intercept is the point 0, 1. If it had been minus 1, it would have been 0, negative 1. Questions on this so far? Now to graph it, I go over to the y-intercept first, 0, 1. And we can put a point. Then we use the slope, negative 3, 4. Now there's 2 directions we can go. We can go down 3 and over 4 to the right. 1, 2, 3, 4. And we make a point and we can draw our line. The other direction we can go is up 3. 1, 2, 3, and over 4 to the left to make our point. Either way, we'll still end up on the same line. I drew that right? Nope. Close enough. And luckily with Alex, once you get the y-intercept and pick one of those 2 points, it'll draw the whole line. Questions on those here? Write an equation of a line that passes through the point 2, negative 3 and has a slope of negative 4. Then write the equation using function notation, where y is equal to f of x. That's all this is saying, this last part, is just replace y with f of x. That's it. So, if we're given a point and a slope, I always default to point slope form. Now, there's some textbooks and some methods that state use y-intercept form, slope-intercept form, and there's nothing wrong with that. Because we would plug the slope in, plug in 2 and negative 3 is the x and y value, solve for b, and then plug it back in. There's nothing wrong with that. That will get you to the correct answer. I like using point slope because, well, we can plug in negative 3 and 2 for our x1, y1, and plug in negative 4 for the slope. I only have to plug it in once. I don't have to plug it in, solve, and then plug it back in. Because if we solve for this here, Well, the negative negative makes a plus. We can distribute the negative 4, which gives us negative 4x plus 8 minus 3. So y is negative 4x plus 5. Here's the equation. There's it in function notation. All we did was replace y with f of x. Yep. Any questions on any of this here? Now, I believe, if I was looking over this correctly, that some of the problems on this here will ask for a solution point or a point on the equation or point on the line or a solution. I think solution point's what they go with. And what they will give you is this here. The number of correct answers for this part here is infinite. It doesn't matter what it is. Austin, give me a number for x. Doesn't matter what it is. Negative 2. So if I said x was negative 2 for this here, four times negative 2 is positive 8. Positive 8 plus 5 is 13. So for this problem here, you could plug in negative 2, 13, and it would say, yes, that's correct. It's a point on the line. It is a solution for this equation. That's it. If I wanted to, I could pick 0, and the y value would be 5, because negative 4 times 0 is 0, just leaving us with 5, so 0, 5 is the solution. You could plug in 0, 5 instead, and it'd say, yes, that is correct, because that is a point on the line. There is an infinite number of solutions for that there, because any x, y that makes the statement true is the correct answer. So you just need to pick one. Any questions on this here? Determine the average rate of change in blood alcohol level from x1 equals 0 to x2 equals 1. Slope. Change in y over change in x. So we could say we're going from 1 to 0. They gave us the x values. Did they give us the y's? Well, technically, no. We have to find them. Because on the graph, at 0, x, the y value is 0. And at 1, it is at 0.06. 0.06 minus 0 is 0.06 over 1. So the average rate of change between 0 and 1 is 0.06. Does that actually, the pink line is the slope given there, that slope. Does it actually relate to the graph itself? No, because the graph is not a straight line. That's where we get this average part. It's not the actual rate of change, it's the average rate of change, our best guesstimation. We can do the same thing from 1 to 2. So we can say 2 minus 1. I'm doing 2 minus 1 because if we do that, the denominator will not be negative. The numerator, so at 2 we have 0.09, and at 1 we still have 0.06. Well, 2 minus 1 is 1. 0.09 minus 0.06 is 0.03. So the average rate of change from 1 hour to 2 hours is 0.03. Interpret the results from parts A and B. Well, A has a faster rate of, or a higher rate of change than B. Questions on this here? This here is the last problem. Now this here seems like it'd be more difficult than doing normal average rate of change, but they're not really. Because average rate of change in y over change in x, is our y2 minus y1 over x2 minus x1. Now the two x values they gave us are -2 and 0. And again, the way that we arrange the x values for this here doesn't matter. And when I said it here with x or with y, whichever ones we plug in first, the order doesn't really matter. So when we were plugging in y's earlier, we just needed one to start with, and then we need another one to follow. Just like with x here. I have the two x values already. I'm just going to plug them in. -2 minus 0. That's fine. It just means whatever y value is connected to when x is -2, it's going to have to go first. Now to find it, well, they gave us a function here, yes? We just have to plug -2 in for x. So we're saying -2 squared minus 1. Well, -2 squared is 4. 4 minus 1 is 3. We'll have to do the same thing for when x is 0. 0 squared minus 1 is -1. Now we just need to simplify. -3 minus -1 is 4. 2 minus 0 is -2. And 4 minus -2 is -2. And that's it. So the change in slope from x equals x1 equals -2 to x2 equals 0 is an average rate of change of -2. All we had to do was find the y values, plug it into the slope formula, and we are done. That's it. Questions on any of this here?